The value chain starts with the raw material bauxite, a clay-like soil type found in a wide belt around the equator like in Brazil. Bauxite contains more than 50% alumina, which is the most important raw material for making primary aluminium. Alumina is separated from the bauxite by using lye. Everything else is filtered away before the alumina is dried into a white powder that is then shipped to the metal plants. Energy for the process of electrolysis is another important input factor. That's why aluminium plants are normally situated in locations with a secure access to abundant electrical power. Alumina has a high melting point and is converted during the electrolytic process. In the electrolytic cells, an extremely high direct current is run between the negative cathode and a positive anode, both made of carbon. The anode is consumed in the process as it reacts to the oxygen in the alumina to form CO2. Liquid aluminium is tapped from the cells and is cast into extrusion ingots, sheet ingots, or other ingots depending on how it will be processed further. Hydro is working to minimize the impact of production on the environment. The technology Hydro have developed is becoming more and more energy efficient and helps to reduce climate gas emissions. Production in Norway is based on renewable energy in the form of hydroelectric power. In 2010, production started at the most advanced aluminium plant, located in the Persian Gulf. Qatalum operates with their most innovative technology. Roughly 14 kilowatt hours of electricity are required to produce 1 kilogram of aluminium. That's as much power as 30 TV sets use in 1 hour. Thanks to its efficient production, Hydro currently produces primary aluminium at a lower cost than most other producers and is the leading supplier of most cast house products. One of Hydro's advantages is metallurgical expertise. Several research and technology centres are working to further enhance both production technology and material properties. The properties of aluminium change when small quantities of other metals are added to produce aluminium alloys. These can give greater strength and ductility, all depending on what the metal is used for. And they can make aluminium easier to form into various products. In Hydro's value chain, the metal takes one of two main routes. It is either made into extrusions or rolled products. 2/3 of the primary aluminium Hydro produces is refined in their own rolling mills. Here, the sheet and foil are made that are used in packaging, cars, and buildings. Sheet ingots are warm rolled down to thin sheet. The sheet is rolled at speeds of up to 60 km per hour. In the thin gauge mill, even thinner sheet and foil are produced. A 7-meter long sheet ingot can be transformed into 40,000 meters of foil. Ullrich Aluminium's Ullexco site has sourced press equipment from world-renowned OEMs in Japan, the USA and Europe. Our structural alloys are sourced from Ullrich Aluminium. Current certification includes ISO 9001 from BVQI, brands approved to produce cladding system, and are the only extruder in New Zealand certified to produce Lloyd's Register certified product. Billets are delivered to Ullrich Aluminium's Ulexco site in Hamilton and are segregated into individual alloys and sizes in the storage yard. All documentation for each alloy is completely traceable, providing cast numbers and alloy compositions for further certification if required. Orders are entered electronically at each branch and printed out in the planning office. Each job is then imported into the factory's production control system, planned and scheduled before being released to the die shop for preparation to go to the extrusion lines. Each die is polished by hand for improved surface finish, assembled and taken out to the press ready for production. Dies are then heated in the die ovens and when ready, loaded into the extrusion press. Each billet is measured and cut to length automatically by servo drive log saw. The material is then heated in an induction oven before being discharged to the press for production. Once loaded into the press, the ram comes forward and extrudes the aluminium through the die. The aluminium billet is then pressed with great force through a die, a device that gives the metal its desired profile. Exit temperatures of over 520 degrees Celsius are required. The profile is then led out into the twin pullers that assist the profile while extruding. Heavy sections and structural alloys are passed through a water quench system, due to the cooling rates being critical to final tempering process and resulting tensile properties. Once cooled, the profile is then straightened by two large hydraulic jaws at the end of the cooling table. The profile is then cut to the required length and stacked onto skips ready for the final tempering process. Sections of up to 15 meters long are then placed into the aging ovens to gain ultimate tensile properties. The extrusion then gets a final dimensional and hardness test, before being transferred to the packing department. Sections are then either spiral wrapped or plastic interleaved into packs and labelled ready for shipment. Lloyd's certified material or upon request, Ulexco profiles are sent for independent tensile testing at Metal Test Laboratories in Auckland. A sliver of metal is cut from the material, then machined into a dog bone shape. This is then placed into the tensile test machine, and then force is applied until the section breaks. The tensile results are then calculated and a report sheet produced. A representative of Lloyd's Register is present to witness all testing of certified material. Ullrich Aluminium's Ulexco division only use the best quality raw materials, dyes and equipment to produce extrusion for a wide-ranging variety of structural, architectural, marine and industrial applications. For any extrusion or rolled product needs that you may have, please contact your local branch today.